Hello there. I am Mrs. Katrina Naldosa from Pasay City North High School M. De La Cruz campus, and I will be your teacher for General Mathematics this first quarter, week 5, day 3. And our objective is to solve exponential equations and exponential inequalities. Let's start with exponential equations. For our first equation, let's have solve 5 to the x is equal to 625. Let's just rewrite first the given. We have 5 to the x is equal to 625. Then the next step is to find the common base. In this case, 625 can also be written as 5 times 5 times 5 times 5, which makes it having a common base with 5 to the x. So we could write this as 5 to the x is equal to 5 to the 4th. And let's recall, there is a property of equality of exponential equation, wherein we say if we let b equal to 1, then b to the x equals 5 to the y if and only if x is equal to y. So we could say that if there are equal bases, therefore, we will have equal exponents. In this case, 5 to the x times 5 to the 4th, we could now cancel the 5. And we are only left with x is equal to 4. So we'll just bring down the exponent as basis. And there you have it. It's already solved. We have x is equal to 4. Next equation. Let's solve for 1/3 to the x power is equal to 81. In this case, we have a fraction. The other one is a whole number. So let's just move it here so that we could solve it properly. So the next thing that we are going to find is the common base. That's always the first step when we are solving exponential equation. In this case, let's take a look. Let's recall the properties of exponent. The first property is b to the 0 is always equal to 1. So meaning, any base raised to 0 is equal to 1. The next thing, we have b to the negative n is equal to 1 over b to the n. And the last one, we have the law of rational exponents. We have b to the 1 over n is equal to nth root of b. So in this case, in 1/3 to the x, can we write it with a whole number as a base? Yes. We could use the law of integral exponents. So we could write 1/3 as 3 to the negative 1. So we have 3 to the negative x is equal to, so we have 81, can be written also having a base of 3 because that is the same as 3 times 3 times 3 times 3. And we could write it as 3 to the 4th. So in that case, what should be next? Yes, cancel the bases. So we have to cancel the common base, and we're only left with negative x is equal to 4. Since we are looking for x, we need to divide both sides by negative 1. So we have negative x divided by negative 1 is equal to 4 divided by negative 1. And we are left with x is equal to 4. Let's now go to the third equation. For the third equation, let's solve for 9 to the 2x minus 1 equals to 3 to the 8x. So we have that particular given. Next thing, find the common base. Find the common base, we have 3 squared for 9, and we just copy 2x minus 1 is equal to 3 to the 8x. There you have it. You have the common base. And the next thing is to cancel the common base. Remember the property of equality of exponential equation. So we could cancel the common base, and then we need to bring down our exponents. We're only left with 2 times the quantity of 2x minus 1 equals 8x. Then the property that we are going to apply is the distributive property of multiplication over addition. In this case, we have subtraction. So we have 2 times 2x, which is 4x, and 2 times negative 1 equals negative 2. And then we just need to bring down 8x. So in this case, we need to combine the like terms in each side. So for the left side, let's just have the one with the variables. We could use addition property of equality, or we could transpose, easily transpose. So let's transpose 8x to the other side, which give it as negative 8x. And then we copy positive 4x. And then how about the negative 2? Yes, it's a constant, so we could now transpose it to the other side. So it becomes positive 2. So we're only left with negative 8x plus 4x equals 2. Now let's solve for x. So we've got negative 4x is equal to 2. And then we could divide both sides by negative 4. We can now cancel the negative 4, and we're only left with x is equal to negative 1/2. The lowest term of 2/4 is 1/2. And that is our final answer. So after equations, let's talk about how to solve exponential inequality. So for the exponential inequality, let's have the first example for that one. We have 3 to the x plus 1 greater than 243. So let's copy again. 3 to the quantity of x plus 1 greater than 243 for the given. And then, same thing with the exponential equation. We need to find the common base. The only difference is the inequality symbol. So we could have, for 243, that could also be written as 3 times 3 times 3 times 3 times 3. So 5 times that we're going to multiply it by itself. So let's have 3 to the quantity of x plus 1 greater than 3 to the 5th. So we could now say it's the same. If we have property of equation of exponential form, we have the property of inequality. So we could just cancel the common base. And we're only left with the exponent. Then we solve for x. We have x plus 1 greater than 5. And we could just simply transpose positive 1 on the other side. You will be getting x is greater than 5 minus 1. And we have x is greater than 4. Let's have second inequality in a different form. Solve 25 squared greater than 5 to the quantity of x plus 1. So we have to find the common base. So we could write 5 squared for the 25 greater than 5 to the quantity of x plus 1. Next thing, cancel the common base. So we're only left with 2 times 2 greater than x plus 1. Now we could now multiply the 2 and 2, so we have 4 is greater than x plus 1. And we could also transpose. We have to transpose positive 1 on the other side, giving us negative 1. So we're just going to copy positive 4 and then greater than x. Now let's solve for x. Negative 1 plus 4 is equal to positive 3, greater than x. But we are looking for x. So it would be better if x is at the left side of the inequality. So we could say that x is less than 3. Take note of the sign. We flip the sign over because we also change the sides of the inequality. So we have x is less than 3. Take note of the inequality sign. We have flipped it. So let's have the next example. of inequality. The third inequality, we have 1 over 2 to the quantity of 4x plus 1 less than or equal to 1 over 512. So I know what you're thinking. We have here integral exponents. So let's find the common base. Take note of the integral exponents here. So we're going to write this as 2 to the negative 1 times the quantity of 4x plus 1 less than or equal to 2 to the, for 512, we have to multiply 2 by itself 9 times. So we are going to get 2 to the negative 9. And then let's just copy the inequality symbol. We have less than or equal to. Now that they have common base, we could now cancel them. So cancel the common base. And we're only left, let's bring down the exponent. We have negative 1 times the quantity of 4x plus 1 less than or equal to negative 9. So let's now distribute negative 1. So we get negative 4x and then negative 1 times positive 1 equals negative 1. And then we have less than or equal to negative 9. We could now transpose the negative 1 to positive. So we get negative 4x is less than or equal to negative 9 plus 1. And we have negative 4x less than or equal to negative 8. And in that case, since we still have negative 4, we divide both sides by negative 4. So, cancel it. We're going to get x is less than or equal to. But take note, if both sides of the inequality are multiplied or divided by a negative number, the sense of inequality is changed. A while ago, the sense of inequality was changed because we changed also the position. But this time, we divided a negative number. Therefore, it will become opposite. Instead of writing x is less than or equal to 2, we could say that x is greater than or equal to 2. So those are the examples on how to solve exponential equation and inequality. Let's have a recap. To solve exponential equations and inequalities, the equating exponents property is used, wherein you need to find the common base. Next thing, the laws of exponents are recalled for easy reference. And lastly, the basic rules in solving inequalities are used. And that's all. And that ends our lesson for today. Did you understand it very well? If not, you may still go back to the lesson presented in your module. If today's lesson is very clear to you, congratulations! You may now start answering the exercises in your module. Good luck and God bless!